Well, hey everyone, I'm excited to bring you an amazing guest, Professor Sifrid. Okay, he's the author of this book right here, Cancer as a Metabolic Disease. This is my new favorite book. Incredible. You need a little bit of biochemistry to get through it, but there's a lot of parts that are really easy to understand. And Professor Sifrid has taught and conducted research in the field of neurogenetics, neurochemistry, and cancer for more than 25 years at Yale University, Boston College. He's published more than 150 scientific articles and book chapters, and is on the editorial boards of Nutrition and Metabolism, Journal of Lipid Research, Neurochemical Research, and ASN Neuro. So welcome, and I really appreciate you spending some time talking with me today.
Oh, thanks, Eric. It's nice to be here.
Absolutely. I think it's important to start out, if we could, on the big idea here, where, and kind of, if you could do it in layperson's language, just to describe the difference between a normal cell and cancer cell. I think that's important to just talk about that.
Yeah, well, there are many differences. The prime difference in my mind is the difference in the way the cells generate energy. And all the cells in our body need to generate energy. And otherwise they die. You know, I mean, energy is energy. So our whole bodies, we breathe in oxygen and we give off CO2 and produce water as byproducts of aerobic respiration.
So aerobic respiration basically is how normal cells or healthy cells make energy. They take the protein, fat, and carbs with oxygen, that's aerobic, equals energy.
The tumor cell, on the other hand, pretty much functions without oxygen. So in order to function without oxygen, this is referred to as fermentation.
So the term fermentation is a primitive or ancient system of how cells can make energy without oxygen. The two main fuel sources for cancer are sugar and glutamine, which is a protein.
So all tumor cells, as far as I can see and as far as I've looked at, are more dependent on fermentation for energy than they are for respiration for energy, using oxygen. So this is why they live in hypoxic environments. They can survive in these environments because they primarily ferment. And when you ferment, you become limited in the types of fuels that you need, because oxidative phosphorylation, respiration, is an extremely efficient way to generate ATP, energy.
So the term oxidative phosphorylation is the final stage in respiration, which is how normal cells or healthy cells make energy.
You need a little bit of material like glucose or some other fat or whatever, and you can generate large amounts of energy just from respiration. But if you don't respire, the fermentation pathways are less efficient, therefore the substrates have to be present in large amounts. So the tumor cell is dependent on large amounts of glucose and large amounts of glutamine. And those are the two primary fermentable fuels. So the differences between a normal cell and a cancer cell is primarily the way they generate energy. The tumor cell needs to ferment. The normal cells can respire.
Got it. And can you touch on the origin of cancer? Because I think mainstream research is really focused on this genetic piece, but they're not getting into the metabolic or the damage to the mitochondria. Can you touch on that?
Well, I mean, that's the oncogenic paradox.
So oncogenic means something that causes tumors, and paradox in this context means something that sounds logical but leads to an unacceptable conclusion.
Cancer can be caused by many different insults to our body. Carcinogens, you know, people look at that and they say, well, that's why we call something a carcinogen, because it has the potential to cause cancer in laboratory animals and humans. You know, radiation causes cancer. Viruses cause cancer. So the question is, how are these provocative agents causing cancer? The gene theory says that the carcinogen will cause mutations, and the mutations then lead to dysregulated cell growth. So you have to say, what is the primary characteristic of tumor? And it is dysregulated cell growth. So how does a cell under normal conditions, become dysregulated in its growth. So, for example, a carcinogen is thought to cause a type of mutation, which will then cause the tumor cell to become growth unrestricted. And if you look at radiation, is thought to cause mutations. Some viruses are thought to cause mutations, and these mutations were thought to be the cause of the cancer. However, every one of those same provocative agents also damages the mitochondria in the cell, the very organelle needed for normal respiration. Now, what happens is a carcinogen will enter into the mitochondria, leading to the formation of ROS, reactive oxygen species, which are carcinogens and mutagens.
So the term reactive oxygen species, ROS, is a reactive compound containing oxygen. Can be formed from within the cell as a byproduct of something, or externally from things like smoking, chemicals, drugs, radiation.
So what happens, the mitochondria produces ROS, which then causes the mutations. So the mutations are an effect of the damage to the respiration, not the cause of the cancer. The cancer and the mutations are both effects of the damage to the respiration. So this changes the whole game as to what the nature of this disease is. And we went through and documented very carefully all of the different agents that cause cancer, and every one of them first damages the respiration, leading to ROS, leading to the mutations. So this whole concept of mutations is mostly nonsense. It's absolutely a misdirected effort, which is and the tragic consequences. Over 1,600 people a day are dying from cancer as the result of this tragic misunderstanding of the nature of the disease.
Wow. So have you ever done any research or heard about research being done using something like IP6 phytic acid as a powerful antioxidant to counter some of the free radical damage?
Well, that's more, it would be in line of prevention. Mm-hmm. So, if you can prevent free radical damage to your mitochondria, you're going to prevent cancer.
So a free radical is an atom with an unpaired electron. Normally atoms have paired electrons. Free radical has unpaired, so it makes it highly reactive. Antioxidants give up their electron to stabilize the atom, making it neutral.
Cancer does not start with normal mitochondria. So things that would be reducing reactive oxygen species or inflammation or things like this would all be important in preventing the disease. But once the disease starts, you have an altogether different strategy that's needed.
Wow. Are there microscopic cancer cells in pretty much everyone? Is there any data on that?
I'm not sure about that. I mean, most healthy tissues, you don't see cancer cells. You only see cancer cells when they become enough to see. They make these statements. We all have cancer.
Yeah.
We all. Those cells are usually destroyed. And taken care of. Well, we turn over our cells all the time. When a cell gets damaged, it's turned over. I mean, we have a maintenance system. They would turn over the cells. A cancer cell, it would be a cell that would not be turned over. Now, do we have precancerous lesions? I think if we have focal inflammatory sections, we would have certain, these are referred to oftentimes as polyps or something along these lines, small growths and things, but they're generally benign. They're not of a more invasive malignant characteristic. So I guess you can say that we probably have these things, but it's only when the tumor cell begins to invade the local environment and proliferate that we have an issue.
Got it. So discuss some of the research that you talked about in some of the other videos using ketogenic intermittent fasting and also DON, and maybe you can define that.
Well, DON is a glutamine analog. I don't have the structure memorized, but it's 6-azo-noreleucine, and the acronym, of course, is DON, D-O-N. But this is a glutamine targeting drug. We have not found any drug more powerful than DON at this point. Because cancer needs the two fuels, glucose and glutamine. So basically, the ketogenic diet is targeting your glucose and shifting the whole body off to ketones. Tumor cells can't use ketones because you need a good mitochondria. And if people say cancers use ketones, that would mean they have a normal mitochondria and they wouldn't be cancer in the first place. So you find a lot of misinformation and misunderstanding on a part of a significant number of scientists, by the way, that still are confused by this. So it's not just the lay public. They depended on the scientists who themselves are also confused, many of them, not all of them, about these issues. So the tumor cell needs glutamine and glucose. Some tumors are more dependent on glucose than glutamine. Some are more dependent on glutamine than glucose. Many of them need both glucose and glutamine. So it's one of these kinds of things. But if you take away both glucose and glutamine, I don't know if any tumor cell, none of them that we have ever found, can survive without their two key fermentable fuels. So DON is one of the drugs that targets and takes away the glutamine, whereas the ketogenic diet takes away the glucose. So together, these two work synergistically together, and would be effective, in my mind, of probably managing the vast majority of all types of cancers. The question is, there's not a single hospital, cancer research center anywhere in the world that's doing this. So this is the reason why we have 1,600 people a day dying from a disease.
Yeah.
It's just becomes clear, you're not doing the right things. If you did the right things, you wouldn't have, these people would be alive.
Right. And what kind of some success have you seen on these experiments that I watched another video that you're combining these three strategies and getting some pretty good, amazing, major effects.
Yeah, we are. And when we do it, we haven't really, if you go back in the literature and look at DON with patients, some people did really well and some people didn't do so well. And none of the previous studies ever targeted glutamine simultaneously with targeting glucose, with glutamine and glucose. So people use ketogenic diets and think you're going to cure cancer with a ketogenic diet. Not if it's a glutamine dependent tumor, you're not. Mm-hmm. So people have to realize that if you don't hit both fuels simultaneously, and they always say, well, the cancer cells are smart. They're not smart, and they adapt. They don't adapt. They're just using the fuels that are in the environment. And if you don't take the fuels away from the environment, it's going to look like they're adapting and it's going to look like they're smart, but they're not. So they're dependent on two fuels. And if they have access to those fuels, they will survive. If the fuels are taken away, they will not survive. It's not a complicated problem. No. It's just that when you're chasing genes and you think cancer is a genetic disease, you don't think about any of this stuff.
Right.
I mean, it's just that, where are you looking? So it's not, when we do it in our preclinical systems, which are the best there are, because we developed the real models for representing real cancer, it's very hard to kill these in the mouse. But when we combine the two strategies together, we're getting great success. And we are targeting glutamine in patients, not with DON yet, because it's not available in sufficient quantities. People don't know how to use it. A lot of clinicians are concerned about this or that. But, it's less toxic than most of the stuff they're already giving these poor cancer patients. Right. So what's going to happen? I mean, we're working with clinical groups and oncology groups in different countries, which are more open to trying these kinds of things. And we are achieving great success in a number of patients for all kinds of cancers, because cancer is one disease. It's all the same. Whether you have a lymphoma, a brain tumor, a colon tumor, a breast tumor, a bladder tumor, it's all the same. They ferment. It's such a simple. It's just like you can kill the whole group of them just by knowing how to use one tool. So it's astonishing. And who's doing this? Nobody. Only because people don't understand. Go down to the top oncology clinics and tell them what I just told you, and they look at like deer in a headlight. They wouldn't know what it's not. But it's not that lay people understand this better than the guys who are actually treating the disease.
It's all very, very exciting. So I want to thank you for the interview, and I really appreciate what you're doing so much.
Oh, thank you, Eric. Nice to have your support. Thanks.
Absolutely.